Hey guys, how's it going? I'm back here with another video, and today I decided to bring this video where I'm going to be showing you guys how to build really cool animations in React using the Firmware Motion library. So if you don't know, Firmware Motion is a really popular library in React which allows you to build animations with barely using any CSS. Actually, I believe in this video I won't even need to use any CSS, which means I will only be using pure JavaScript. There's a lot of benefits to using Firmware Motion to animate your elements, and I will go over all of them while at the same time building some really cool animations using the library. If you want to check out the documentation, I'll leave the link in the description. I'm also going to leave the link to the sandbox that I used for this video, so if you're interested in that, just check in the description. And yeah, that's basically it. Let's get into the video. Okay everyone, so differently from a lot of my tutorials, in this tutorial I'll actually be using the codesandbox.io website just because I thought it would be easier for me to show all the changes that I'm making whilst I'm writing code. Usually changes aren't really immediate, so you don't really need to be seeing one thing next to each other, and while recording the video usually that's fine. But for this specific tutorial, I want you guys to have a clear view of what is happening on the screen of the website every time I make some sort of change to my code, and I felt like this way would be better. So let's get started writing our code. So basically you can see I have an empty React application over here. Obviously it has some CSS, it has like a gradient on the background, but it doesn't really matter because the point of this video is just going over the Firmware Motion library. So in order to start out, you need to install the Firmware Motion library. To do that, you'll have to go to your React application and either run yarn add Firmware Motion like this, or run npm install Firmware Motion. So this is the name of the library. This will install the only package that we actually need, and after you do that, it should be fine. So like I mentioned, Firmware Motion allows you to create animations in JavaScript without actually using CSS. The reason why this is cool is because animations in CSS are really annoying. I think everyone can agree with that. I know that I've wanted to make animations in certain projects, and I actually didn't because I honestly felt like CSS was annoying to work with. So having a library like this will facilitate it a lot. Not to mention, it allows you to integrate all of the cool stuff from React, such as like states and page renders, with your animation, which is something that is a bit harder to do with CSS, including like using variables and stuff. So that's something that I honestly feel like it's a positive, and one of the main reasons why you should use this library. So to get started with the library, I'm gonna import over here at the top from Firmware Motion, and I want to import something called motion. Now this motion variable over here will be really important because every time we have some sort of element in our screen which we want to animate, we need to use this motion variable to tell Firmware Motion that this is an element that we want to animate. So let's come over here and just add a div inside of our code. Now, since I'm using this code box, like this code sandbox project, it already has some CSS, so the div automatically looks like this beautiful little square over here. But if it is your case, don't forget to make your element look like whatever you want to animate, right? So it doesn't have to be a div, it can be a button, it can be whatever HTML element you want. All of them will work the same. But for this video, we're just gonna make animations with this little square over here. And if you want to check the CSS, basically this is all the CSS that I'm using in this video. I didn't write, it comes with this example project. So how exactly are we going to animate this element? Well, in order to animate it, I'm going to actually just come over here and say that this div is actually a motion.div. So every element in HTML that you want to be able to animate, you notify Firmware Motion that the element is supposed to be animated by putting this motion dot before the name of the element. If it was a button, you would do motion dot button, right? And it will work normally. This is a div. However, now it also takes in the props that motion, that the motion variable over here provides us. And what exactly are those props? Well, the first one is really important, and it's the main one. It's called animate, right? And this animate prop over here takes in an object which is the end state of any animation we want to create. So for example, if I want to say that our animation is basically just sending this square, I don't know, 100 pixels up, then I would come over here, say y, because y is a property that we want to change, right? The y-axis, and send it 100 pixels up. I actually just realized that I forgot about this, but in actual HTML, 100, when it's positive, it goes down. When it's negative, it goes up. But you can see that the animation is pretty smooth, right? Every time this element is rendered, it has this little simple animation. You can actually do it for the axis as well, and make it positive if you want to as well, to move to the right. But we're basically not writing any CSS, and it already has the possibility of animating itself. Now, another thing you might also want to do is determine some sort of initial state to your animation. So, for example, we're only determining over here the end state of our animation. If I want, for example, something else to be changed inside of my animation, not only just the x-axis, I can say something like the scale of the actual square will start at 0 and it will gradually increase to 100%. This is something we might want to do, right? Well, to do that, we'll give over here the initial prop to this div, then just say that initially the scale is 0, but as it progresses and at the end, it will become 100%. If you don't know, scale is just the size of the element. So as you can see, it kind of gives this pop effect because it starts at 0 and it ends at 1. And it already looks pretty smooth, right? You don't have to do anything. I don't know, I really like the way Firmware Motion animates its elements. Now, if you remember, I mentioned that one of the benefits of Firmware Motion is the fact that you can integrate React stuff like states into your animations. And a great example of this is, for example, creating some sort of animation where when you click on the actual element, or anywhere else, it can be a button, but in this case, let's just click on the element. It will trigger some sort of different, it will trigger the animation or a different kind of animation or a continuum of the animation, right? You can do a lot of stuff with this. The example we're going to do is pretty simple. We're going to create a state over here, which it will determine whether or not we want to rotate the square or not, right? I thought that that would be a nice example. So we can create a state over here called rotate, and we can say set rotate over here, and then we're going to set this equal to react.use state, right? And we'll set this equal to false actually, but basically it's a boolean, and if it is true, then it should rotate to 360 degrees. If it is false, then it should be 0 degrees. Now, if you remember like angles and geometry, this basically means that if the animation is not working, it will rotate, and if this is false, it will rotate, and if it's true, it will also rotate. So basically what this effect will create is whenever we click on the element, it will rotate in itself, which honestly I find it really cool. So how exactly would we do this? Well, we'll just remove this over here. We're not going to do the same animation as we had before, and the animation now is pretty simple. All we're going to say is we're going to say that the element will rotate, but if rotate the state is false or it's true, then it will become, we want to rotate this to 360 degrees. But if it's false, we'll rotate it back to 0 degrees. Now, it is false initially, so it is 0. But in order to change this, we're going to give an on-click on this div, which we can do, and say that whenever you click on this div, we want to set rotate like this to be equal to the opposite of what it is right now. So if it is true, it will become false. If it is false, it will become true. What this means is initially it is false, so the rotate value of this will be 0 degrees, meaning it looks like a normal square. But if I click on it, you can see it kind of shakes, right? All it's doing is it is rotating in itself. And now this is true. So this is 360 degrees. But if I click again, it will keep rotating. So now it has this little cool animation whenever I click on it. Now you can do other stuff. For example, instead of rotating, I can try moving this whenever I click on it. For example, I can call this move and say set move. Then instead of rotating, I'll say, I'll move this on the x-axis and say that if move is true, then we'll move this 200 pixels to the right. If it's false, we'll move 200 pixels to the left. And then all we're doing here is we'll say set move to be equal to not move. The same thing we did before. But now if we really think about the logic, move starts as false, right? So this element will be negative 200 pixels. But if we click on it, it should become true, meaning it should now go to 200 pixels, which it does. But now if we click on it again, it will become false. So it goes to negative 200, and you can go like this forever. And it looks pretty nice. This animation would be super complicated, but it is not, because Firmware motion makes everything look very simple. Another thing you can do with this is kind of add a delay to it. So for example, if I come over here and I use a transition prop, which is very important in Firmware motion, I can give certain properties that have to do with the transition. So one example would be some sort of delay in the actual animation. So to give a delay, I'll just say something like the amount of seconds I want the delay to be. I don't want to make it super big, so I'll just put like 1 second. And you can see that there is a delay before the animation is complete, right? So if I click now, it should wait 1 second and then do the animation. And that's exactly what happens. Same thing with this. It waits a second. You can actually put this to like 3 seconds, and obviously it will be way more. Yeah, it was waiting 3 seconds to go left, and now if we click again, it will wait 3 seconds to go right. But delay is really cool. If you ever need it, this is how you do it. But although delaying the animation is really cool, the transition prop, like I said, is much more important than just that. There's actually 3 different types of transitions that you can make using Firmware motion, and I'll go over each one of them. The first one is the one with the type tween. And this one is very useful, so you'll use it a lot. Basically, this is a type of transition where you can determine the duration of it. So if you don't like how smooth or how long it takes for the transition to complete from its start, you can actually use the type tween and do something like that by adding the duration to this transition. So for example, if I want the transition to run slowly, I can say that the duration will be 5 seconds, and now you can see it runs a lot slower, but it still runs the same. It's just at a different pace. And yeah, if I click again, you'll see the same thing happens. But if I set it to something like 0.2, you can see it's almost immediate, right? Yeah, it's almost immediate. I don't know how small it goes, but you can see it's going pretty fast, right? And this is basically what the tween type is. Now the next type of a transition that we can have, it's called spring. And this, by the name, you can imagine that it actually is used to simulate real-life physics, right? And there's a lot of properties you can use with the spring type. There's like stiffness, there's bounce, which is really cool. Bounce is basically, you can add bounce to your transition. So if I add like, I don't know, 60 to it, you can see whenever the transition happens, there's like a bounce to it, right? You can obviously don't use 60 in this example because it is too much. But if you do like 5, you'll see that like, I don't know, it's still pretty strong. You can play around with the values, but it is used mainly to determine like how your element will execute based on real life physics. And the next type is the inertia type. Now this type is like both the spring and the inertia types are mostly used whenever you need something very specific or something that is more like physics related animations. But inertia is also really cool. If you use the inertia type, you can determine something like velocity. And if I set the velocity to something like 40, you see it moves, but it's acting as if there is some sort of resistant force. I can keep moving it by just clicking on it. And you can see it might have implications in your project. I don't know if it does, but but this is something I can do with it, right? It keeps moving whenever I click on it, which is cool. But this is the last type of transition that you have in Firmware motion. Now that we talked about transitions, I want to point out the fact that you don't really need to use the animate property to make your animation happen. That property basically will render an animation after your component is rendered. So after the div is rendered, it will initiate that animation, meaning that it might not be useful for certain use cases, right? There are some use cases which you need an animation to be triggered specifically based on some sort of event, right? And Firmware Motion actually has a whole section on this where they focus a lot on different ways in which you can interact with your elements to trigger an animation. And I really wanted to show you guys some cool things that you can do with this. So this is actually called gestures. And there are a couple of different gestures that you can implement in Firmware Motion. One is you can say that you want your thing to animate while you are hovering it, right? You can see there are 4 different types, right? So while you're hovering it, you can say something. You want the scale of it to be 2, right? You're just scaling it 2 every time you're hovering it. And now if I hover it, you see it grows in size, right? Now this is something you can do really easily in CSS, but like I mentioned, you don't really just need to do something simple like this, right? You can increase in complexity to a point where doing this in CSS wouldn't be possible, and you can now do it using React, right? So there's more you can do with this. There's also while you drag, right? And this while drag is really interesting because it allows something really cool. First of all, if I just do the same thing I did with the while hover and just say that whenever you're dragging, you want to increase the scale by 2, right? You'll notice immediately that this is only triggered whenever you left click on the element and tries to drag it, right? But what exactly is the point of doing something like this? You actually want to see this element being dragged whenever you left click on this and move it around. So if you want to simulate that and you want to animate your element to do that, all you have to do is you just have to put the drag property over here, which means that now I can literally just grab this and move it around. It's that easy, right? And you can see that if I drop it, it does contain some physics to it, which we can actually prevent it from moving around loosely like it's happening right now by adding some constraints to it. For example, if, and by the way, I'm gonna remove this while drag over here. Let's just be dragging it individually, right? If I want to only drag it in the Y direction, I can say that the drag is equal to Y, right? And now it doesn't allow me to drag left, but it allows me to drag up and down. You can do the exact same thing for X and it will work perfectly. Now, there's more than just this conditions. For example, I can come over here and say drag constraints and say that you can only drag up to, for example, I don't know, 50 pixels to the left, but you can drag this about whatever you want to the right? We're not going to put any constraints to the right. You'll see that now, if I try pulling this to the left, it will not allow me to move past 50, right? It will drag back and it won't allow me to go any further. But if I try moving to the right, since there's no constraints, it will allow me to do that perfectly, which means it is working and there is constraints to our left and right elements, right? So basically this is what drag constraints is. You can use drag for a lot of stuff. There's a lot of cool stuff you can do with it. I'm gonna leave a link for some cool animations that you can either copy or just get inspired by, which I actually really liked while looking at the codesandbox.io for Firmware Motion, because I actually found a bunch of stuff while looking for this video. The last thing I want to talk about is how to actually implement continuing animations, right? So what do I mean by that? Well, normal animations in CSS has something called keyframes, where you're actually able to set your animation to keep changing depending on at which point of your animation you're in, right? Over here, we've seen that we can set an initial and an end to our animation. So we have an initial state and an end state. But by using keyframes, we're able to change the animation midway through, determining on where we are in the animation. So if we want to do something like keyframes inside of our project, we will have to animate. So we'll give an animation property. Then let's try to animate this in a way so that it is consistently rotating and rotating back, right? It'll keep doing that. We can do something like rotate is equal to, and instead of putting something like 200 over here, where it will obviously rotate 200 degrees, we'll actually put an array where it will show you the values of where it should be, like in a sequential order, right? So it should start with 0 rotation, then go to 200, then from 200 it will go to 0. And if we save this, now if I save this, you'll see that it keeps the animation goes from 0 to 200 and then 200 to 0 in a perfect way, right? Now obviously it stops because it gets to the end. I can actually use transition, like I mentioned in the past, to make this animation last longer by adding the duration property over here and saying that it takes like 5 seconds to finish the animation or something like that. But sometimes I want this to actually run forever, right? So to run forever, I can actually make this repeat how many times I want. And the repeat property comes inside of the transition over here. I can say that I want to repeat this animation, for example, 2 times. And I'll make this go quicker. I'll make this 1 second. And you can see it will rotate twice, right? It will do the animation twice. I'll refresh it again and you'll see once and then twice, right? Now, if we want to make this forever, I can just say infinity over here. And oh, I forgot to put the comma. And now, as you can see, it will run forever. You can actually make some other cool stuff with this. Like instead of just adding a rotate to this, you can make this rotate while it also moves in the X direction. I can say that by keyframes, it will start at 0, then go to 200, then from 200, it will go to 0. And you'll see that the animation now will keep moving back and forth while doing the rotation. To make it even cooler, I'll try to do from 0 to 200, then from 200 to 0, then from 0 to negative 200, and from negative 200 to 0. And you'll see it looks kind of funky, but but you can see at least it's working. And keyframes are really cool. They're mostly, I use a lot of it whenever I do animations like this. And they're very important if you want to make your website look cool, which is exactly what I'm doing with this over here. So yeah, that's basically it. I really hope you guys enjoyed this video. If you enjoyed it, please leave a like down below and comment what you want to see next. Subscribe because I'm posting every week, and I would massively appreciate it if you guys could help support the channel. And I hope you guys enjoyed it, and I see you guys next time.